Okay, this video will cover a review for your quiz on sections 1.1 to 1.3. So the first question says to give two other names for line AE. Let me go ahead and fill in points A and E. There, up here is A, and down here will be C. So another name for line AE could be, we could just reverse the letters and call it EA. We can also call it AC because C goes beyond E, or even EC. That would cover, because again, notice the arrow on top, the picture of the line, it continues in both directions forever. Another name for plane S, remember you can name a plane with 3 points that are non-collinear. So as long as you don't pick points DEB, that would name this plane. So I could name it DEF. I could also call it plane EBF. Another example could be plane DBF. These are all examples of another name for plane S. 3 collinear points, you would need to find points DEB. That would be an example of 3 collinear points. And then we also have a line right here, and 3 collinear points on that line would be AEC. Again, you could list these points in any order. To find the intersection of line AC, which is this blue line, and again, this needed an arrow here, and then the white plane S, that intersection of a plane and a line is going to be a point, and it intersects it at point E. From section 1.2, this is where we learned our segment addition postulate. We learned how to check to see if two line segments were congruent. We also saw our ruler postulate. So for this, notice that each one of these little markings here are broken into 8ths. So if right here is 1 inch, then this one would be 1/8, then 2/8, and then where B is 3/8, this line right here. So the length of A to B, this segment, is 1 3/8. To find the length of CE, we're going to use our segment addition postulate. So CE is going to be made up of adding the length of CD plus the length of DE. CD is 7, DE is 15, so CE will equal 22. On number 3, it's asking us to plot the 4 points, and then it's going to ask us to connect the points to make a segment FG and HJ. So if I first graph point F, it's at -3, +5. So I'm going to go over to the left, 1, 2, 3, and then up to +5. Right here will be point F. And then I'm going to graph G at +2, 5. If I connect these two and make segment FG, to find the length of FG, I can either take the 2 order pairs that represent F and G. I'm not using the order pair, the Y out of this order pair, because it's the same. I can go ahead and subtract big minus small of the X's, absolute value the result, and the length of FG is going to be 5. Now I'm going to graph H at 3, 1, and J at 3, -3. I need to find the length of this segment. So again, I could take the 2 order pairs H 3 comma 1, J 3 comma negative 3. I'm not using the 3's. I'm going to subtract 1 minus negative 3. 1 minus negative 3 becomes plus, and this gives me a length of 4. So the length of HJ equals 4. So because 4 does not equal 5, I'm going to say that FG is not congruent to HJ. Now, one other nice thing about this is when you have it graphed on a coordinate plane, you can also count the units. So I could have counted 1, 2, 3, 4, and you could see that HJ has a length of 4. I could do the same thing for FG up here, 1, 2, 3, 4, 5, and this has a length of 5. So again, if you're just given coordinates and you don't want to have to graph them, then you can go ahead and just subtract and then find the absolute value. However, if you're given a coordinate plane and they're already graphed for you, you can count the units. So then number 4, notice segment KL here is on a number line. So to do this, I can do big minus small. L is at 4. K, notice there's no number here, is sitting at negative 3. So 4 minus negative 3 becomes 4 plus 3. I get 7. So the length of KL is 7. Now I could have also counted 1, 2, 3, 4, 5, 6, 7 and find that it has a length of 7. Let's go on to section 1.3. This is where we're calculating the midpoint and distance, and we also learned about something being bisected. So let's go ahead and give ourselves a visual. It says AB bisects CD at point E. So let's go ahead and draw CD. And then I'm going to show that it's been bisected by AB. So AB is bisecting CD. So because I see that something's been bisected, and I know my picture is a little off, but as soon as I see the word bisect, this tells me that from C to E, this is going to be congruent from E to D. So if CE has a length of 2 1/4, then that tells me that ED is also 2 1/4. So to find the length of CD, all I have to do is add CE plus ED, and that will give me CD. So 2 1/4 plus 2 1/4 gives me 4 2/4. Simplify, 2 1/2. You could have also taken 2 1/4 and multiply it by 2. Remember, when you multiply fractions or mixed numbers, you need to make the 2 1/4 improper. And then I could multiply. I'm going to simplify, change the 2 to a 1, the 4 to a 2. I get 9/2. And when I turn that into a mixed number, it's 4 1/2. If you told me the answer was 4.5, that is also the same answer. For the next one, it's telling us that point M is the midpoint. So that immediately tells me that over here, this is M, and it says it's the midpoint of X, Y. So that tells me that XM is congruent to MY. I will need this information to find the value of X. Once I find the value of X, then I can plug it back in and substitute it for X in the expression 2X plus 7 to get the length of XM. So I'm going to go ahead and solve for x. So I know that xm, so my equation that I can set up here is I know that because m is the midpoint, I know that xm is congruent or equal to my. xm is 2x plus 7, my is 8x minus 23. I need to solve for x, so I'm going to group my variables. It cancels it from the left, and now I'm left with 7 equals 6x minus 23. Sort of running out of room here. I'm going to go ahead and rewrite it over here. 7 equals 6x minus 23. I will add 23 to both sides. I get 30 equals 6x, divide by 6, and x equals 5. I now take this 5 and I'm going to substitute it into 2x plus 7. So 2x plus 7, take out x, replace it with 5. 10 plus 7 is 17. So the length of xm equals 17. The next question is asking me to find the coordinates of m, and m is the midpoint. So I'm going to be using the midpoint formula for number 3. Recall that x of the midpoint, y of the midpoint. Remember, the midpoint is a coordinate, and you can find that by doing x1 plus x2 divide by 2, y1 plus y2 divide by 2. I'm going to go ahead and label my ordered pairs, my p and my q, as x1, y1. That'll be p. And I'm going to label q as x2, y2. So I'm going to plug them in. So my x1 is 2. My x2 is negative 8. And then it's divided by 2. Then I'll do the same thing for the y. y1 is 6, negative 6, plus y2, which is 0, divided by 2, part of the formula. And now I'll simplify. I get negative 6 over 2 for the x, negative 6 over 2 for the y. I can divide these, so my order pair for my midpoint is negative 3, negative 3. This is the coordinates of point M. On the next slide, it's asking us to find the coordinates of the other endpoint. So here, again, I'm still using the midpoint formula. So I'm going to set the x of the midpoint equal to x1 plus x2, divide by 2. And then I'm going to do the same thing for the y of the midpoint. y1 plus y2, divide by 2. I'm going to label my point M here. This is my midpoint, so this is going to be my xm and my ym. Point G, this will be x1, y1. H, this is going to be my x2, y2. So let's go ahead and substitute what we know. So the xm is going to be 4. Setting that equal to 5. I do not know x2. That's my variable. Divided by 2 is part of the formula. To solve for x2, I'm going to multiply both sides by 2 to get rid of the fraction. I'm left with 8 equals 5 plus x2. Subtract 5. And the x of my endpoint is going to be 3 equals x2. This canceled. 8 minus 5 is 3. So far, for point H, I've got the x Now I'm going to find the y. So again, y of my midpoint is -1, setting that equal to 3 plus my y2, which I don't know, divided by 2, part of the formula, and now I can begin to solve. Multiply both sides by 2. This cancels the fraction. I'm now left with -2 is equal to 3 plus y2. Move the 3. -5 equals y2. So the coordinates of point H, or the coordinate is going to be 3, -5. That is the other endpoint. The next question is a word problem. You'll have a word problem on your quiz. So here it's asking us to find the distance between the swing and the sandbox. The swing is at order pair 7, 2. The sandbox is at order pair or coordinate -3, 8. I'm going to use the distance formula to find the distance between these two coordinates. So again, the distance formula is x2 minus x1 squared plus y2 minus y1 squared, all under a square root. I'm going to go ahead and label my order pairs and give one of them the coordinates of x1, y1, and then the other one as x2, y2. So for here, let's say the red one is x1, y1, and 7, 2 could be x2, y2. It doesn't matter which one you label as which, just stay consistent. So let's go ahead and plug in these 4 numbers into the formula. So I'm going to do x2, 7 minus -3 squared plus 2 minus 8 squared, all under the square root. This becomes 7 plus 3. This becomes -6. 7 plus 3 is 10. I can go ahead and evaluate this. This becomes 36. 10 squared is 100. I end up with the square root of 136. I'm now going to do a factor tree for 136. 4 times 34. Keep breaking it down till it's prime. Now look for pairs. I have a pair of 2's. When you make a pair, that becomes a perfect square. So now it comes out of the radical as a 2. These 2 do not have pairs. Multiply them back. And the simplified radical is 2 square root 34. So that would be the distance between the sandbox and the swing. So that concludes the in-class warm-up for the quiz. This is a good way to study for the quiz, in addition to the textbook review that is posted on Canvas along with the solutions. So again, tomorrow you have a 10-question quiz, and you must show work for all the questions.